Hey everybody, this is Mr. Munson and we are still in Unit 9. This is the last section of logic and reasoning. We're going to look at writing a proof. All right, let's go ahead and get started. So one of the I can statements for this section is I can complete an algebraic two-column proof. So these kind of problems are usually set up with you're given something to be true and you're to show that something else is true, okay? Given that that first part is true. This is always the last line of my two-column proof. So probably the best way of just learning how to do two-column proofs is to see how to do it. So what you do is you draw lines like this, and on the left-hand side you write the word statements. Okay, so that's a statement I'm going to make. I'm going to profess that those statements have to be true. And on the other side are my logical reasons why that I'm saying that that statement's true. You know, this wouldn't make sense at all in this proof, but I could say, hey, you can't see this, of course, as I'm recording this, but I'd say, hey, you know what? It's kind of misty outside and a little bit cloudy. And the reason? Because it's raining. All right, let's go ahead and start writing this column proof. So usually one of the very first things we write is ones. This is a statement one and then the reason one, so it matches up. And the things I write are going to be usually the given, okay? And the reason I can say that's true is, well, it's given as being true. Then I enter in statement number 2 and reason number 2's line. Now, I would always tell my students, hey, before you try to run a two-column proof, make sure you understand, is this thing actually provable? Does x equal 3 if that given thing is true? So before we go any further, I want to make sure in my mind that that is true. So let's just quickly run down through this and see if algebraically this will equal x equals 3. So what's my first step? I'm going to go ahead and distribute that 3 through. Now, if you don't mind, I'm not going to, show all the steps for this, taking the 3 and sending it through. I'm just going to simply say I'm going to distribute that 3 through. Now, my next step, and see if you can figure out what it is before I say it, but my next step is I'm going to subtract the 2x's from both sides. I'm going to subtract 2. I'm going to gather my x's over on the left side so I can eventually get down to x equals a number with x being on the left-hand side. And again, I hope that you can follow my reasoning here without me showing the subtracting 2 from both sides or the 2x from both sides. So then what do you think my next step will be? See if you can guess it, and then I'm going to write the reason, or I'm going to write it and tell you the reason. I hope that you guessed that, I'd subtract 15 from both sides, and there I have that. And then my next step, divide both sides by 10, and sure enough, I get x equals 3. So now I'm just going to write a two-column proof for that. So if you remember, I distributed the 3 through. Okay, just because I do something doesn't make it true. But I learned back in the original parts of algebra that I'm allowed to take that 3 and graphically draw, arrows and show the 3 goes through, distributes. And when I do that, I create a different looking equation, but it's equivalent. It hasn't changed anything other than the way it looks. So the reason I'm going to write down that I'm allowed to do that is the distributive property. Okay, and there I have it. So see if you can guess what my line 3 statement's going to be. And basically, I'm not going to show my work. I'm going to alter that equation to a new equation. And again, I'm working this equation just like I did before to get it to be x equals 3. So see if you can guess what my line number 3 statement is and the reason for it. All right, so basically I'm following the equation I showed you just earlier, how I worked this thing down to x equals 3. I'm following that on the right hand or the left hand side, and I'm stating and writing what I said was the reason for me allowing me to do those steps. I subtracted, so I'm going to say that's the subtraction property. My thing is still an equation that's equal to each other. The left side is still equal to the right side. I haven't changed the equation, just the looks of it, right? And so I usually put in parentheses what it is I subtracted. Well, I subtracted 2x from both sides. That makes it easier for the reader to figure out what I did. All right, off you go with number 4, line 4. See if you can figure it out on your own. It's not such a hard one. All right, let's go do number 5. And there I have it. X equals 3 because from line 4 to 5, I divided both sides by 10, and that gave me X equals 3. I know I'm finished because what they asked me to prove is now my last statement. Okay? Let's move on. All right, now let's take that same idea and apply it to a little bit more, I wouldn't say difficult, but more thought-provoking process, and that is to try to prove something in geometry, something we're not really used to doing as much as solving equations, okay? So you might find this one a little bit more of a stretch of your brain. You have to really think on this. You can't just kind of halfway do it or whatever. Get into the game with me. Make sure you follow along and listen to my reasoning on this, and it makes sense. Again, before I do this, I'm going to make sure I can, in my mind, come to a conclusion that given this information up top, that I can prove that the two triangles are going to be congruent. So I need to come up with an idea. So let's first of all write the information into the drawing. There's 34 there, 34 there. And then it tells me CA is congruent to CD. Very good. And then they want me to prove that triangle ABC, so ABC, it follows that path from the 34-degree angle. DEF from 34 to that angle, okay? So it looks like it follows the same path. It starts at the angle of 34 in both triangles, and it goes across the sides that are not previously marked. So that shouldn't be too hard. I just got to come up with a way. So this is what I know. I know vertical angles are congruent. They don't have to tell me that, so I'll be able to bring that into my argument just because that's something I know. Vertical angles are congruent. And now I know that this angle is congruent to this one. This side is congruent to this side, and of course this vertical angle is congruent. So by angle, side, angle, these triangles are congruent, okay? Now, remember, we don't have to put anything after that. We can just write angle, side, angle. All right, let's do it. Just like before, create your two-column proof. Okay, so some people, when they're writing proofs like this and they're given a whole series of given statements, they bring those things in, they kind of dump them all at the very beginning. There's nothing wrong with that. Since this is going to be an angle, side, angle proof, I'm going to make sure I bring in things in that order, making sure that they kind of match up like that, okay? So let's start. Now, I'm going to eventually say the measure of angle A and the measure of angle D is equal to each other or congruent to each other because they have the same measure. So I'm going to bring in that very first line that they gave me that the two measures are congruent. The definition of congruent angles is this. If two angles have the same measure, they're congruent. That's the definition of congruent angles. So I've checked off the idea that they have the same measure, so I therefore logically can say that they're congruent. The reason I'm saying that is because that's the beginning of my angle side angle proof. I've proven I've got one set of angles that are congruent. Now what I'm going to do is go about showing the sides are congruent. Okay, there I have CA is equal to CD. That's given to me. Now, being equal is not the same thing as saying congruent. We know that if those two sides are equal, then they're congruent. So let's go ahead and say that now as a fourth line. The definition of congruent sides is that they have the same measure. Okay, so here I have the two sides that have the same measure. That should allow me to make the logical statement that the two sides are congruent. The reason I can say that, definition of congruent sides. Well, that's good news because that means that I have just proven a set of sides are congruent. So I'm almost on my way now. I just need to show a set of angles are congruent. All right, so my fifth line, if I'm following an angle side angle proof, would be to show another set of angles are congruent. DCE, which is that angle up here at C, DCE, and angle BCA are congruent because they're vertical angles. Okay, so I've completed it. Now I've got that the two triangles are congruent using angle side angle. Now I'm ready for my last statement. All right, I'm going to state that the two triangles are congruent. That's the thing that they wanted me to prove. I'm going to state it just like they did. And I'm going to say that the reason I'm allowed to say that is angle side angle. I'm done with it. Okay, here's the two-column proof. Go ahead and copy this one down. This is your answer bank. So you're going to steal from here to put answers into these spots. So you got to go find the reasons that you're allowed to say this. This was actually a problem that was on a previous SOL that's on a released test now. So I want to see if you can do this one. Go ahead and write it down, think it through, come up with the answers. Come back and check your work here. So if you're stuck and you've come to check it, again, I would have you go back and look at the drawing and the information and ask yourself, is it possible for me to prove that the two triangles are congruent? You know, what else would I need to know? If that's a hint for you to go ahead and go back and see if you can do this on your own. So for me, I know AC is congruent to AC because of the reflexive property. We've talked about that quite a bit in class. Okay, and so then we have a side, and then another side congruent. So this is going to be a side angle side or side 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 proof that the two triangles are congruent. Hopefully that was like easy as pie for you. Let's move on. Okay, and that's it. Here's your try it problems. I'll scroll through it for the smaller devices so you can see each problem. I hope that was helpful. Take care. All right.